Hi, this is Priyankesh. I hope you all are doing great. Welcome to the MCQ to solution session. In this session, I'm going to discuss all the questions that we have provided today. Okay, so let's get started. So let's begin with the first question. In this question, what we have to do, we have to find out the equation of tangent. Okay. So in order to find out the equation of tangent, we have x and y in the parametric form. So first of all, we need to find the uh, here we need to find the slope. Okay, so that is dy by dx. So for that, what we'll have to do, we'll have to differentiate y function with respect to t. So this will come out to be 3b cos square t, and the differentiation of cos t will come out to be minus sin t. Okay, and then differentiation of x with respect to t will come out to be 3a sin square t into cos t. Okay, now divide on both the sides, and 3 gets eliminated, cos t gets eliminated, sin t gets eliminated. Here dy by dx comes out to be, it is coming out to be minus b upon a cot t. Okay, now find dy by dx at equals to pi by 2. So this will come out to be, since the value of cot pi by 2, this will come out to be minus b by a cot pi by 2. See, this value is 0 because because of cot pi by 2 is 0. Okay, so the equation, in order to find out the equation, we know that the equation of tangent is y minus y1 equals to x m x minus x1. Okay, this is the equation. So here at the place of x1 and y1, the point which we have given to us, will have to put value t by 2 in this. Okay, so this will x1 will come out to be a sine q pi by 2. So value of sine pi by 2 is 1, so this comes out to be a. Okay, and value of y1 will come out to be b cos q pi by 2. So cos pi by 2 is 0, so this will come out to be 0. Okay, so here x1 is a, and y1 is 0. So as we know that the slope is 0, so irrespective of the value of x1, this component will become 0, and y1 has come out 0, so the final answer is y equals to 0. So according to the option b is the right one. Okay, let's move to the next question. That is question number 2. In order to solve this question, what we have to do, we have to take log on the both the sides. So by when we take log, x will come ahead and it will become x into log y, and this will come out to be y minus x into log e to the base the e. Okay, and this value will become 1. So now let's differentiate with respect to x. Okay, so this is x into differentiation of log y is 1 upon y into y dash. Okay, and then we'll write log y, because here I'm following product rule, first second function, so we'll writing second function, and then we'll differentiate first function, that is x. So this will come out to be here differentiation of x will come out to be 1. Okay, so here we have y minus x, so differentiation of y is y dash minus differentiation of x is 1. Okay, now let's take y dash term on one side and rest of the term on the other side. So this will come out to be log y plus 1. Here it is y dash minus x upon y dash. Now let's take y dash as common. So this will come out to be 1 minus x upon y. That is y dash y minus x upon y. Okay, here it is log 1 plus y. So the value of y dash is y upon 1 plus, y upon y minus, this is minus x, and in bracket 1 plus log y. But if we look at the answer, so there is no value. So ultimately we have to find out the value of here. We have to replace this value. Okay. So in the beginning from this expression you can see that here we have taken log and the value has come out as x into log y equals to y minus x. Okay, so here what we will get, x into log y equals to y minus x. So here x upon y minus x equals to log y. Well, let's add 1 onto the both the sides, and by arranging here we will get x y minus x upon y minus x, and here it is 1 plus log y. So x and x gets eliminated, we'll get value of y upon 1 minus x, and here it was it will come out to be 1 upon log. Sorry for that. So this will be 1 upon log y. Okay, so this will come out to be 1 plus log y upon log y. Okay, now let's eliminate, let's put the value of y upon y minus x in the differentiation. So this comes out to be 1 plus log y upon log y. Okay, here it was 1 plus log y. So we'll multiply it and it will come out to be 1 plus log y whole square upon log y. Okay, so that is the thing. Now let's move to the next question. So according to the question, option A is the right option. Okay, let's move to the question number 3. So that's very easy question. In to solve this question, we have to take log on the both the side. It will come out to be log y, and cos x will come ahead, and in the in second part, it will come out to be log cos x. So let's take this as second, this take as first, and apply the product rule. So this will come out to be 1 upon y into y dash, and this will come out to be log x, and differentiation of log x, log of cos x will be 1 upon cos x into minus sin x. Okay, and then we'll write second function as it is, and we'll differentiate first function. So this will come out to be minus sin x. Okay, now here you can switch this y onto the right side, and the value of y is it cos x to the power cos x. So y dash will come out to be cos x to the power cos x. Okay, and you can take sin x here common, so this will come out to be 1 plus log cos x into minus sin x. So if we go by the option, so you can see this is the correct answer. Let's move to the next question. So in this question, we have to find the second order derivative. To find this, what we'll have to do, we'll have to use this identity. P cos inverse x equals to cos inverse 4x cube minus 3x. Okay, so if we put it, so this cos 3 cos inverse x, this will become cos inverse in a bracket 4x cube minus 3x. Okay, now the question has become very easy. Cos and cos gets eliminated. 4x cube minus 3x, and this is y, so y dash will come out to be 12x square minus 3, and y double dash will come out to be 24x. So option E is the right option. Now let's move to the next question. I told you already this question is very important from the point of view of IGIDR. This formula is very important. Pdx of a to the power x is a to the power x ln a. Okay, so here if we differentiate this function, so this will come out to be 5 to the power cosec x into ln 5, because at the place of a here we have 5, and the differentiation of cosec x is minus cosec x into cot x. So let's go by the option. So this is the right option. Let's move to the next question. That is question number 6. Again, that's a very easy question. Now let's differentiate with respect to x. So x differentiation of exponential function is come out to be same. That is e to the power x. But here we don't have x. Here in place of x we have this expression. So we'll have to follow the chain rule. So differentiation of this 9x square will come out to be 18x, and differentiation of minus 7x will come out to be 7. Differentiation of 6 will come out to be 0. So by the expression, this is the right option. Now let's move to the next question. This question is very important because definitely you're going to get this kind of question in your IGIDR Entrance Exam. So please pay your attention. Okay. Now we have hx function defined as f of gx. Okay. So let's differentiate it. This will come out to be h dash x and this will come out to be f dash gx. Okay. Now we'll again further differentiate. So this will come out to be g dash x. Now let's put the value h dash which we have to find, that is h dash 2. So here this will come out to be f dash in a bracket g2 multiplied by g dash minus 2. Okay. The value of minus g dash 2 is 5. Okay, so we'll put 5 here, and the value of g minus 2 is also 5. So this will come out to be f dash 5. And the value of f dash 5 is minus 3. So minus 3 into 5, this will come out to be minus 15. So option A is the right option. Now let's move to the next question, that is question number 8. In order to solve this question, generally we have function is in the form of y equals to fx, but here we have a function that is x equals to f of y. So we'll have to first transform this function into this form in order to find out this derivative. So let's do it. Okay. So x equals to 1 plus y upon 1 minus y. So now multiply. So this will come out to be x minus xy. Here we have x 1 plus y. Now let's solve it further. So this will come out to be x minus 1 and here it will come out to be y plus xy. So here y will come out to be x minus 1 upon x plus 1. Now you can apply quotient rule in order to find the derivative. So derivative will come out to be y dash, that is dy by dx. Okay. So this will come out to be x plus 1 whole square x plus 1, and differentiation of x minus 1 is 1 minus x minus 1, and differentiation of x minus 1 is 1. Okay. On solving, you will get x plus 1 minus x plus 1 upon x plus 1 whole square. So x and x gets eliminated. The value will come out to be 2 upon x plus 1 whole square. So the option B is the right option. Now let's move to the next question. That is question number 9. I've already mentioned in my lecture that they'll ask you to assess the nature of the differential equation. So if we find the dy by dx here, so we'll have minus y x plus y upon x square. So let's say this is fx comma y. In order to find whether this equation is homogeneous or not, we have to check whether this function is homogeneous or not. So this fx comma y is minus y upon x plus y whole upon x square. Let's to assess the nature, you need to separately check whether these two functions are homogeneous or not. These has to be homogeneous. Homogeneous. Now alternatively you can check the whole function as homogeneous. So let's enhance the value of x as lambda x and enhance the value of y as lambda y. So this will come out to be lambda y bracket में x lambda x plus lambda y upon lambda square x square. So this will come out to be minus lambda square is common and y x plus y whole upon lambda square and x square. Lambda square gets eliminated. So you can see that this can be written as lambda to the power 0 fx comma y. So this is homogeneous function and here it is dy by dx which is of order 1. So you can say this is first order homogeneous equation. Now let's move to the next question. This question is very important because you hardly find this formula in some books. So this formula, please note in your books, textbooks. This formula is d dx of mod x is x upon mod x. Okay, so keep this thing in your mind. Otherwise, you will end up in finding the wrong answers. Okay, so the differentiation of the above function will come out to be x minus 2 upon x minus 2 mod of x minus 2, and this will come out to be x minus 6 upon mod of x minus 6. Okay, now in order to find the derivative value at x equals to 4, this will come out to be 4 minus 2 upon 4 minus 2 plus 4 minus 6 upon mod of 4 minus 6. Okay, So here the value will come out to be 2 upon minus 2, but here the value will come out to be minus 2 and upon in bracket as in the inside the mod this will come out to be minus 2, but due to mod it will become positive. So 2 and 2 gets eliminated and here it will come out to be 1 minus 1. So the final value will come out to be 0. So option A is the right answer. Now let's move to the next question, that is this question is based on partial differentiation. Here zx is the partial differentiation of z function with respect to x. So generally we denote it by del z by del x. What does it mean? It means while differentiating the z function with respect to x, we'll take y as constant. So this will come out to be 2x minus y, and we'll further differentiate this x minus y. So this will come out to be 1 minus 0. So finally it is coming out to be 2x minus y. Now we'll find z y, that is del z by del y. So here we are differentiating z function with respect to y, keeping x as constant. So this will come out to be 2x minus y, and in bracket it will come out to be 0 minus 1. Okay. Now this will finally come out to minus 2x minus y. Now we have to find the value of x zx plus y zy. So this will come out to be x 2x in bracket x minus y and minus 2y x minus y. So we'll solve it further. So it will come out to be 2x square minus 2xy and minus 2xy plus 2y square. Okay, so this will come out to be 2x square minus 4xy plus 2y square. So finally, option B is the right option. Now let's move to the next question. So here we have to find the point of inflection. I have already mentioned in my lecture series that in order to find out the point of inflection, we have to first find the critical points. For that, you have to find the equate first derivative equals to 0. This will give you critical points. Okay. And after finding critical point, you'll have to find the second derivative and put these point into this. If you get the value of f double dash equals to 0, so that point, that the value of let's say x equals to a, this point will represent point of inflection. Okay, so remember this thing. Okay, so now let's differentiate the above function f dash fx equals to 3x power 4 minus 8x cube plus 6x square. So f dash x will come out to be 12x cube minus 24x square plus 12x. So equate it equals to 0. This will, now we can take 12x as common. This will come out to x square minus 2x plus 1 equals to 0. This is nothing but the whole square of x minus 1. So this will come out to be 12x x minus 1 whole square. Okay, so from here we'll get the value 0 and 1. Now we have to find the second derivative. So let me do it here. So this will be f double dash x will come out to be 12 3 the 36x minus 48x square plus 12. Let me uh, copy this expression. Now we have to check the nature of this f double dash x at x equals to 0 and x equals to 1. So f double dash 0, this will come out to, this expression will become 0 and this will come out to be 12, which is not equals to 0. So this is x equals to 0 and x equals to 1. F double dash 1 will come out to be 36 into 1 minus 48 into 1 square plus 12. So ultimately this comes out to be 48 minus 48. This will cancel out and finally it comes out to be 0. So x equals to 1 is the point of inflection here. Okay, so let's go by the choices. So we have option A is the right option. Okay, now let's move to the next question. Here it is asking find out the local maxima and local minima. So in order to do this, we have to first differentiate this function. This will come out to be differentiation of sine 2x is cos 2x and differentiation of 2x is 2 and differentiation of x is 1. Now we'll have to equate equals to 0. So here we'll get cos 2x equals to 1 by 2. Now you just look at the limits. So here we have x is lying between minus pi by 2 to pi by 2. So 2x will lie between minus pi to pi. Okay, so here we will get 2x equals to minus pi by 6 and pi by 6, because the value in which cos is equals to 1 by 2 is pi by 6. But on the other hand side, we'll also get minus pi by 6. So, we'll get pi by 3. Sorry. So here we'll get x equals to minus pi by 6 and pi by 6, these two values. Now, let's suppose you are you have few minutes left and you have to solve this question. So I would advise you can simply mark the option A. But if you have time, please check it. Okay, because the time span for solving such question is very less. So they are not going to play with the option in such question. But in other question they can play with. Okay. So let's check the double derivative. So double derivative will come out to be differentiation of 2 cos 2x will be 2 minus sine 2x into 2. Okay, so finally it is coming out to be minus 4 sine 2x. Okay, so let's move to the, now we have to check the value of the second derivative at the 2 point. So second derivative is f double dash x is minus 4x sine 2x. Okay, now let's check this at pi by 6. So this will come out to be minus 4 sine 2 into minus pi by 6. Okay, so sine minus theta is minus sine theta. So this will become plus and this will come out to be 2 sine pi by 3, and sine pi by 3 is sine 60, that is root 3 by 2. So this will come out to be 2 root 3. Okay, so here this is greater than 0. So by Mc-Mal condition, that is if it is greater than 0, so it will be minimum. So here this will come out to be local minima. Now next point, you don't need to check it, you can simply mark it, because you can see that here it will be local minima. So option A is the right answer. Now let's move to the next question, that is question number 14. Here in this question they are asking about the coordinates of the point on the curve. uh, this is the given curve, and the tangents, they are talking about the tangents. So we are going to get 2 points, okay, which is passing through the origin. So first, let's differentiate this function. So this will come out to be 2x plus 3. Now let's take the point is x1 comma y1, at which we are getting the tangent. Okay, so at this point we'll get y dash equals to 2x1 plus 3. This will represents the slope of the tangent, and now we got the slope and we have a point. So we can write, this is slope and this is point. So we can write the equation of tangent. Okay, so this will come out to be y minus y1 equals to the slope, that is 2x1 plus 3, and in a bracket you will get x minus x. They have also mentioned that it is passing through origin, so the y value will be 0 and the value of, sorry, x value will be 0. So this will be 0 minus y1 and this will come out to be 2x1 plus 3. Okay, in another bracket you will get x minus x. Now this is minus and minus gets cancelled out. This will become plus y1 and this will become 2x1 square plus 3x1. Okay, so let's suppose this equation, this is equation 1. This point will also exist on this curve. So this will become, we have a curve that is y equals to x square plus 3x plus 4. So x1 and y1 point is lying on this curve. So let's assume this as equation 2. And our equation 1 was y1 is equals to 2x1 square. Okay, let me question. So 2x1 square plus 3x1. Now equate both these equations. So this will come out to be x1 square plus 3x1 plus 4, and this will come out to be 2x1 plus 3x1. Now 3x1 and 3x1 gets eliminated. We can transfer this x square, x1 square to the right side. That will come out to be x1 square equals to 4. So x1 will come out to be plus minus 2. Now corresponding each x1 we will get 1y. So we can put in value of x1 in any of this equation 1 or 2. So let's say at x equals to 2, if I put this in equation 1, so this will come out to be 2 square 3 into 2 plus 4. Therefore 6 4. So it will come out to be 14. So the point is 2 comma 14. Now if let's say if I take x equals to minus 2, so this will come out to be minus 2 square 3 into minus 2 plus 4. Okay, here it will come out to be 4 plus 4 8 minus 6, so this will come out to be 2. So we'll get the point that will come out to be minus 2 and minus 2. Let's go by the choices. Option D is the right option. Okay, here we can see that option D is the right option. Okay, now let's move to the last question of the session. This is again also a very good question. In this question, the equation of tangent line is tangent to the curve. This is the curve that we have, and we have to find the line which is parallel to the line. So we know that any line which is parallel to the line, we have to just simply change this part. Okay, that is the constant term. So let's find the slope of this curve. So this will come out by first derivative. So this will come out by 4x. This will be simply 4x. Okay, now again tangent is having a point of contact with the curve at this point. So this will also satisfy this point. So this will come out to be 4x1. Okay, let's assume this equation 1. Now this as line the tangent is parallel to this line, so the slope of this line will come out like that by shifting y to the right side, and as this equation is the form of y equals to mx plus c, so here m equals to 4, this is the slope, and these two slopes has to be equal. So for here we have 4x1 equals to 4, so we will get x1 equals to 1. Okay, now in order to find the y, just put it in an equation. So this point will also satisfy the curve, so this will come out to be y1 equals to 2x1 square plus 7. So this will be 2 into 1 plus 2 into 1 plus 7, so this will come out to be 9. So we got the point that is 1 comma 9. Now I told you the equation which is parallel to the line, we have to just simply change this thing. So this will come out to be k equals to 0. Now put this point into this, so you will get 4 into 1 minus 9 plus k equals to 0. So the value of k will be equals to 5. So the equation which we are getting here is 4x minus y plus 5 equals to 0. So this is the right option. Now that's all from my side in this session. So if you want some free resources, so you can join us on Telegram by subscribing this channel, and or you can also search IGIDR by PTH. We are preparing for IGIDR 2021 entrance exam for MSc or PhD, so you can enroll in our classroom program by the link given in the description, and also you can subscribe this channel. If you like this video, please share it and subscribe the channel. Thank you.